Hello world, uh, ZT, and I am doing episode 3 of my first season of making my first game. Uh, I am just checking the bitrate right quick before I continue on. I think I set it to like 1.25 instead of 1 megabit, and I just want to see if it has a good constant stream without dropping too many packets, which I think it looks good. Yeah, 1.25. Cool, so that's hopefully just a little more data, so a little more clear. Okay, so let's get started. So what did we talk about so far? Alright, so I put everything in a README, so I guess we can keep track of what we're doing as we're doing it. In episode 1, we went through the basics and the nav mesh agent. Episode 2, rigid body movement, animation movement, and then we're trying to put it all together. So what I see for today is that we're just going to continue to try to put the nav mesh agent movement. Oh, I can put movement on there. Movement. Uh, the rigid body movement and animation movement all together. Figure out who controls what at what point. So that's what we're going to do today. I'm trying to think of anything. Oh, I want to post on Facebook right quick, just saying that I'm streaming. Oh man, and I also gotta like put the name of the episode. Yeah, I wasn't ready. I just came home from work and I'm just doing what I'm doing. Alright. That's me. Okay, so I need to figure out what to call this first. I think if I go to my dashboard it might be a little better. Yeah, I don't know what I call these things. Unity, ETdoFresh, Unity, Season 1, Episode 3. I'll just actually start putting titles of the episode, like putting movements, all movement together. And we're playing not Team Fortress 2, but game development. Sweet. Alright, updates. And let's hide playing not Team Fortress 2, but game development. Mute that. Hide that. I'm in the chat. Let's do a test. Awesome, that's working. Everything seems to be working good. Alright, I put like different things on the stream, so it'll be a little better. I'm going to put this off to the side. Pop out the chat. Minimize my browser. Cool. Frame rate looks awesome. Alright, so now that we are putting it all together, let's see where we left off. So if I hit play, from what I remember, we just have like animation kind of piggybacking off our rigid body. So what I mean by that is animation only takes place if rigid body, it says it has some kind of velocity. So like if velocity is higher than 0, animation, yeah, I think that should be changing, right? Let's see if I go to player, animator, and I move him around. Yeah, oh yeah, the forward. So all we're doing is changing this forward variable in the animation that was came with Unity. So we definitely want to use the other variable turn, and I'm not really prepared to talk about it, so we might just be doing some copying and pasting of code from Unity, or from my other script that I copied from Unity. Cool. So yeah, let's do that. Let's pop open that other scene that I have, or other project that I called Sand City. So I have a movement script here, and we're just going to kind of look at it together. Okay, yeah, this has a lot more stuff, but before I look at all the variables and everything, let's just go over the simple stuff. Like, we're getting our rigid body. We set the rigid body constraints here. It's the same thing as checking off freeze rotation X, freeze rotation Y, and freeze rotation Z, and that's how you do it. It's a little, I think this is a bit mask or something. Basically, it's 1, 1, 1. or if you put a not in front of one of them, it would be 101. Anyway, animator, we got the animator. Navmesh agent, we got the navmesh agent, and we're just saying update the position, don't do it, and don't update the rotation. And then we just set some variables here, like the normal to the ground is just a straight up vector, so up in the y direction. The turn amount is 0, forward amount is 0. So basically this script is also keeping track of the variables that we'll give to the animator in a bit, and original ground. So we're also checking our distance from the ground, so we can check to see if we're grounded, to see if we can jump. So if you're on the ground, you can jump. But if you're not on the ground, you can't jump. So that's kind of what that's all about. So this stuff we're going to start migrating to our code. So I just wanted to grab this script right quick. So we're going to open up our old project just so we can start from, not from scratch, but start from where we left off last time. Okay, cool. Yeah, just checking some stuff right quick on my other monitor. Making sure everything's okay. We only dropped a few more frames. Alright. I'm good with that for now. If it gets more than like 2%, I will start looking at it. Okay, so we got our original scene here. Let's start looking at some scripts. So if we go here, this is the good one. And this is going to be the one we're working on. And I like to do this. I like to actually type it all out because I feel like if I'm typing it out, I get a better understanding of what's actually happening. This is not the script we use either. Or this camera follow, or this command action, or yeah, this all the stuff I kind of started working on. But I just kind of want to put it out there to see if I'm doing it right. So, okay, it didn't load the script I wanted, so let's go ahead and go back to Unity. Go to our scripts. Nav mesh rigid body movement. Reload all. Cool. Close that. Oh shoot! It even closed the one I wanted. That's cool. I'll just navigate to it. I'll find it. That one was in Sand City assets scripts movement humanoid movement. Give me that one too and pop it out. Put it on the left. Put this one on the right. Let's go. Let's make some progress here. Alright. So far, all we have is these three variables. And that's what we're doing. We're getting the navmesh agent, the rigid body, and the animator. I'm going to kind of move stuff around so everything's kind of together. So the navmesh stuff, I'm going to put with the navmesh stuff. Rigid body I didn't really do anything with, except just due to constraints, but I'll just let Unity handle that. And let's not do all this other stuff that I was talking about here on the right hand side. So let's just go straight into the update function. So the old update function I had here was just getting the whether you click the button and setting the destination of the nav mesh. So we have that, and that's called under the update detect, click, and set destination, and that's this script here. So this should equal that, which is great. We're not doing jump or crouch just yet, so we'll skip that. Vector move, get slow radius velocity. I think I was doing that because I was trying to get what the velocity should really be as you're approaching your target. So like if you're within a range of the target, you want to start slowing down instead of going like full speed towards your target and stop. You want to slow down based on your acceleration. Okay, and move update. That's I think where the meat of all of this is. So move update is the function. And then this nav mesh next position equals transform position. We did that here in rigid body movement. We're doing it on the fixed update as opposed to the regular update. I think because we are yeah, I don't know which one would be better, because fixed update is all about rigid bodies, but here we're not even touching a rigid body, we're just touching the nav mesh agent. So maybe I might take that out and put it in the update for now. So I'm going to take that out of here, put that here, because that really doesn't have to do with the physics. That's more to do with the nav mesh agent, which makes sense. Okay, and that's why I love doing this. Just kind of figuring out where things should be, where it shouldn't be, and talking it out makes it so much better. So okay, I'm not going to worry about this get slow radius velocity on animator move. Ooh, that's a good function that I didn't explain, but I definitely should explain. Okay, let me just do the quick 2-minute crash course on animator move. So, and it's just for my benefit too, because I got to remember. If you are loading up like an animation like I did earlier, so let's just do that one more time. Third person character, we get the Ethan model. We load an animation on him. Like, let's just do a walk. Yeah. Yeah, I did this last time. You're not supposed to do it from there. You get the animation and walk. Okay. So he's there. I'm gonna kind of focus on him. On this one, and I hit play. He should just walk, and root motion's being applied, so he basically is moving because the animation contains movement. Great, we understand that. Perfect. So that's apply root motion. But if he had some kind of script on him, which I'll just do right now, we'll create a new script. I didn't do it the right way. Create a new script, and we just call this animation or animator or script. I'm going to be deleting this in a second anyway. But if this, yeah, okay, good. I don't want you here though. I'll just make you big. Okay, so if this script in any way uses this function, void on animator move, I think that's what the function is called. I have it on my human script. There we go, human movement. On animator move, which is exactly what I called it. Great. Even if it's blank, I just return nothing. It's a void anyway. If I go back to Unity, now we see that apply root motion is handled by the script. So we are overriding the root motion that Unity would actually provide us, and we can do whatever we want. I believe, and this is my first time doing it, that all it's doing is transform.position plus equals, so I'm adding to my position, oh lord, I don't even have the animator. We need the animator. So on void on start, grab your animator. Animator. Okay, yeah. Good practice. I was just going to put it in on animator move, but I'm going to show you the good practices, because that's what this is about, right? Animator. Alright, so we got animator. We just say, oh yeah, and actually, before I even do this, by making the script override, if I hit play now, I think he's just going to walk in place. Yeah, he doesn't move because the script doesn't have anything happening yet. And just wanted to check for my sake. So I think if you do transform position, animator.delta position, which is the change in position from the last frame to this frame built into the animation, and you also do transform.rotation. Oh gosh, I don't think you can just plus equal this stuff. I don't know how to work rotation. I am very not skillful in this stuff. It's gonna error out on me, but I'm gonna write it anyway just so I know what in the world it's even returning. Delta rotation. It's a quaternion, so I think you multiply quaternions together like this, times equals. And I think that works. I know no one's watching me, but like if you're in the chat, just tell me if I'm doing it wrong. But okay, now we can see he's moving again, and Now instead of Unity having that default 2 lines of code, we wrote it ourselves. So now we can control it any way we want. So, like, we could do delta positions ×2, and now he's going to be moving twice as fast, and his feet are going to be gliding, and all of that. Dun, dun, dun. So, yeah, you can tell that is not as natural because he's gliding all over the place. But anyway, that is the default on animator move. And, we want to take advantage of this stuff, like the delta position and the delta rotation. And that's all I think I had to say about that. Alright, cool. Sorry. That's something I forgot to mention in last episode that it was very important for this episode. I'm going to close this out. I'm going to delete the Ethan model. And I'm going to delete this animator script. Cool. Alright, back to our comparisons of 2 different scripts. My gosh, yes. Reload all the time, every time. Please. But don't lose my humanoid movement. Alright, cool. So, what are we doing on animator move? We're checking the animator velocity, getting the change in velocity. Okay, so basically here we are getting the animator to move us by adding a force to the rigid body. So like I said, we get to control it. So instead of transform that position plus equal something, we just say rigid body add force. So that's a very interesting way that this can be done. So let's do it. I like to keep all my Unity default functions up here, so I'm going to stick it right in between here. Void on animator move. So what are we going to be doing here? So we are actually not going to be moving the rigid body on this kind of stuff. We're going to put kind of this code up in here somewhere. Okay, so man, I am just thinking. Well, before I guess I copy this code over, and I'm gonna just keep looking through this right quick. Okay, the move update. What I was saying, that was the meat of all of this. We're ignoring crouching. Okay, the move magnitude. So if we're saying the move magnitude is greater than 1, normalize it. So this is basically taking any kind of vector between 0 and 1. And at a certain direction. Let's see, the inverse transform direction. I don't remember what that does. I guess we can always go to Unity site and look up what that does. I think it's something to do with like normalizing the rotation in some form or fashion. So inverse transform direction. Transforms a direction from world space to local space. The opposite of transform direction. So we are just getting the direction from world space to local space. So basically we input move is the direction you want to move in world space, and now we are converting it to local space. So that's all that does. So if we had the local direction and we wanted to put it into world space, we would do transform direction. So, okay, cool. Check ground status. We're not doing that, but that is to see if he's on the ground. Vector 3, project on plane, move, ground normal. Oh my gosh. Mind blown. I don't even know. I forgot. Project on plane. Project on plane. Project on... Oh. Might be better if I just do the actual Unity search. Project on plane. Projects a vector onto a plane defined by normal orthogonal to the plane. So okay, what I do know is the normal is a vector that shoots out of a polygon, so that it shoots out of, like if I have a square, it will be the vector that either shoots that way or shoots this way. So I can't do a square. So yeah, that's a square, and it's going to be a vector that shoots out towards you. If it's facing you. So if the square is facing you, it's the vector that comes out of the center or I think out of the center, right? Out of its pivot, right, to you. So right now, oh, and I think I know what that's for. Maybe. It's starting to click. I'm going to minimize this. So basically, when we check the ground status, we get the normal. Like if we're standing on a flat piece of ground, your normal will be straight up, and all you want is your movement along that surface. So on a flat ground, you want your movement just to be in the z and the x direction. You don't want any y direction. So you're projecting all your vector onto just that surface. Um, so if it's flat, your y will be 0, right? But if it's not flat, your y is going to be, slightly tilted to it however you're leaning, and then it'll be your x and z component as well. So it's very complicated math put in a nice, easy function. So that's all it is, but that's what project on plane is. You're projecting a vector onto a plane. Huh. Very creative naming there. That makes sense. Turn them out is a tan 2, so I do kind of remember this. It's basically to get the angle between two vectors. You do or between two vectors. No, to get an angle from the origin to a point anywhere in space. So you have the origin 0, 0, 0, and then you have this like point anywhere in space. A tan 2 is if you put the movement of x and z, this will be your, yeah, it'd be better if I had like paper or something. But anyway, that's basically angle from the origin to the point. And then the forward amount is how much are you going to be moving in the z direction. So that's all about, yeah. Sorry, I'm just looking at it. Yeah, that makes sense. That just makes sense now looking at it. Okay, apply extra turn rotation. That, I don't know what they're doing, so we're gonna, I think I just, F12 was it? F11. No, F11 like build stuff. I forget, how do you get to the actual function from here? I gotta know this, because if I'm gonna be doing coding, shortcuts are the lifeblood. I can do a Google search and probably find it in a second. Navigate to, go to psi. Alright. I don't remember, so let's find it. Visual Studio, go to function or something. Go to statement. No, not exactly what I want to do. Shortcut keys. I think I saw it. Was it Shift F12? Finds the reference. Yes. So if I'm on here, Shift F12. Nope. Come on, I did it all the time when I used to program. Now I can't remember. That's what summer does to you. Wipes your memory. Okay, cool. 23 minutes and not much done. Alright, move the cursor to the next item. Nope. Nope. Nope, 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 nope. Alright. How to jump to a function quickly. F12 when the cursor is on the symbol you want to go to. Ah, come on. That's what I hit, right? Is my stuff working? Like if I hit F1? Yep, F1 works like a charm. So if I hit... Oh! It's probably not working because, well, first I put a space in here. But the second thing is, it's probably because it's not part of the project. It doesn't want to actually jump to these different functions. So that makes sense. Okay, anyway. Let's just go to the function. Great. Help characters turn faster. This is in addition to root animation. Okay, cool. So, and I did modify this code, so I did not do any of that. Yeah, so nothing here is touching the root. I mean, there's no torque code in here. Okay, sorry. Where am I at? Alright, apply extra rotation. So we're taking the turn speed, we're doing a math F lerp from the stationary turn speed, moving turn speed, and forward amount. So what are these things? I should be looking at the actual Unity code, not my messed up code that is not going to be working very well. So I'm going to close this one out. Let's go to standard asset scripts. Third person character perfect. And then we're going to take that out, move that to the right. Here we go. This is the default Unity code, just because there's a very strong possibility I could have screwed some stuff up while doing this. Alright, so that turn speed, yeah. Shift F12 is supposed to give me all the references. Oh, nice. Oh, so stationary turn speed, something defined by the user. So how fast do you want to turn? And moving turn speed is also, I think, something specified by the user. Yep, it's only in the two places. And forward amount is how fast they're moving forward. Yeah, right? Interesting. So, and right quick, lerp gets from a to and a t. So from to and basically the amount. So if you're moving really fast, you'll be closer to the moving turn speed. If you're moving really slow, you're moving. So if forward is 0, you'll be at stationary. If forward is 1, you'll be at moving turn speed. That makes sense. So you turn faster when you're moving, or I mean, whatever you put in the code, but typically at stationary you turn slower, and then while you're moving you move faster. Okay, and then all you do is rotate on the y-axis. So x is 0, z is 0. Turn amount times turn speed. And turn amount is another variable you specify. Man, it's a lot of variables you specify. Turn amount is not specified by the user though. So where is that taken? Oh, yeah, turn amount is, oh, I see. So turn amount is what the animator gives you. Turn speed is your additional rotating speed, and then time delta time is because you are running this in an update function, so you need to do it. You need to times this by times delta time. Otherwise, you'd rotate way too fast. Okay, I'm understanding. Wow, great. The exploration has begun. Alright. So, now that I'm beginning to understand all of this, let's do some of it. So, and where was that being handled? On the update animator? Yeah. No. It's like move, right? There's a move function. Here we go. Update animator. Oh, apply extra rotation. Right. We're not doing the grounded stuff yet. Scale capsule for crouching. Very cool, but we're not there yet. Prevent standing low headroom. Not there yet. And update animator. We are there yet. So let's see what the update animator does. Updates the forward, updates the turn, updates the crouch on the ground. We're just worried about these two for now, the forward and the turn. And yeah, I'm at 30 minutes. This one might run a little long. It might be like an hour and 30. Okay. Is grounded and move magnitude. Cool. Okay. I'm starting to get it. So back to what we're doing. On update, we are just making sure I'm saying all this right. On update, we are going to move the character. But how are we going to move the character? I say we use nav mesh to move the character, to run this move update function. So let's put that in there first. We have move update, and how are we supposed to move? Vector3 dot. No, I don't put that vector3 here, but it's going to be move update move. And that's going to be a vector. So it doesn't know what I'm trying to do yet, so I can't really make Visual Studio. Well, I'll go ahead and say vector3 move. So now it knows, and then I can generate a method stub for this. I can move it down to below on animator move. Perfect. That's how I like Unity functions up, my custom functions below. Cool. So the nav mesh. Hey, thanks, Shocking Truth. Thanks for following. Dun dun dun. All right. So the nav mesh is gonna do what? Move update. Oh, okay. So the nav mesh is going to say how you're going to move. So it says the desired velocity is going to be x. So nav mesh dot desired velocity is, that's where you want to go. But it's going to be a normalized thing. So what I'm going to do is I'm going to divide it by its speed, because it really just wants a number between 0 and 1. And if I try to just pass the desired velocity itself, it'll return a number that's higher than 1 almost all the time. So your character is going to always be running, even if he's trying to decelerate. He's going to always be running. So you really want this kind of normalized. So I can just do desired velocity divided by speed, or just normalized. No, but that means if I do, you need to divide it by speed. Sorry. Yes. Because if you just normalize it, even if he's like going one direction at 1, it'll still be 1 if it's normalized. But if you divide it by speed, like if he's going 1 forward, but his speed is 5, you'll get something like 0.2, which is the value you want. So, okay. So your nav mesh divided. So your nav mesh agent speed is controlling how fast your character is going to be moving. And your nav mesh agent speed is also going to be controlling how fast your character animates. So okay, we'll get there. We'll get there. Move update. So we have our nav mesh stuff. So we're going to copy the stuff from the Unity default script here. I might actually just copy it. Be devious. Alright, so what are we doing? We're normalizing this, although it's pretty much normalized and less than normalized. Oh, do we want to normal? Yeah, only if it's greater than 1. So if it's less than 1, which most of the time in our slow parts, he'll be less than 1, so the normalize won't happen. Great. Inverse transform, so from world space to local space, we're not doing this check ground status, so we're not projecting anything on a plane. I should be commenting these, not deleting them, just so we can come back to them. Turn them out. We do need turn them out, and I don't like this whole M. Although the M thing is really cool, because for some reason if you do it this way, Unity still just ignores the M underscore part and just gets turnaround amount. But my naming convention is a little different. I'm just underscore turnaround underscore forward amount. I have to be different. I don't know why. It's just the way I program. So we got a turn amount, a forward amount. Perfect. And then the apply extra rotation, which is those 2 lines of code that took me forever to understand, but once I understood it, I'm like, oh man, it's brilliant. Let's put that in here. Oh lord, and then there's other stuff. So stationary speed and turning speed. Yeah, these are things that I guess I should put. Stationary turn speed. moving turn speed, forward amount. So like I said, forward amount determines whether you're at stationary speed, somewhere in between, or at turn speed. So at 0 it's at stationary, at 1 you're at turn speed. And then turn amount is actually already specified. Let's make these fields as well. I think when I was programming in just C#, like I'd always make things properties, but I think with Unity it just feels more natural to make the variables the fields versus the properties, because if you really want to make this like something you can edit in the UI of Unity, you could just be like serializable, let me space that out, serialized field, and bam, now you can edit these variables right in Unity. And it's private if you do it this way. Or you could just take this whole parentheses thing out and make it a public variable, and Unity will show it just fine too. Is that a dot or a speck on my screen? That's a speck on my screen. Okay. Stationary turn speed, moving turn speed. Everyone's happy. I think they have default values for this, so before I open it up in Unity, I'm going to do the default values that they use here. 360 and 180. Cool. Okay, oh my gosh. So crazy. Alright, so if I go to player, go to my script. Got two variables now I can edit with the serializable field, 180 and 360. So yeah, that's another very cool feature of Unity. And now I can edit these values whenever I want during game. Oh yeah, cool man. Yeah, thanks for not talking. If you want to talk, man, be my guest. I'm not very good at looking at the chats yet because I'm always like in my zone and I'm not ever looking at the broadcast to see, hey, who's talking to me? So maybe that's like a skill I need to get. But it's not a skill that I have right now. Yeah, so what are we doing? So we have just a little bit of our animator controlling the nav mesh agents and rigid body, which is like a crazy thing because we're trying to combine 3 different movement engines into one. Alright, so back to Visual Studio. Okay, so if I run this, I don't think anything's going to really happen yet, so let's just keep going. So we have the update, the move update, and all that did was kind of update our variables up top, our turn amount, our forward amount. But now we need to get those variables that we updated into the animator, so the animator knows exactly what to do, like whether he should be running, whether he should be walking, whether he should just be idle. So that's what we'll do next. So we got the move update, and now let's just do the animator update. And I'll just not put any variables. Oh my gosh, I don't want mode. Alright, cool. So we got the animator updates. And so the animator update, I didn't take an extra space here. Okay, so the animator update. What are we going to do here? Should be pretty easy. We're going to take our animator, we're going to set the float. So select the float for movement. Gosh, yeah, I think that's right. Let's look at Unity. Make sure. So if we go to the animator, here are animator values. Oh, it's forward and turn. Those are the 2 variables we need to set. So movement is wrong, forward is right. And then we gotta set the value. And the value is going to be forward amount. Animator.setFloat. Turn? Trune? Trune or turn? Probably turn. Turn amount. So we set the animator up. Awesome. Should I try it? It won't move, but maybe he'll animate. I'm gonna try it. It's always like a scary thing to do. Alright. He's there. Man, I really want the animator and the scene view together. So, okay. Player, where's player? There he is. And then let me get the animator kind of in here just to see what's happening. Okay, so we're in the grounded state. Alright, this is the moment of truth. When I click on the plane, stuff is going to happen. I hope. Whoa, he's moving. He's not supposed to be moving. So I'm already confused. Or am I confused? Alright, he is glitching out. That's awesome. I don't even know. He's like idling and running at the same time. It's so weird. So, okay, I'm definitely have some competing stuff going on. Let's figure it out, shall we? Oh yeah, look, I still have this rigid body movement, which we can't have right now because Animator is going to start controlling it in just a bit here. So I commented the rigid movement out. There we go. Awesome. That's exactly what I wanted. So he's going to like, just as I click around, keep an eye out on the forward and the turn. So like if I click up here, he's moving forward, but then like if I click behind him, he's gonna like have to like, he really wants to move behind him, so he's gonna be like negative moving, and he wants to turn around to go forward moving. One thing I don't know if I like, and it's probably because he has no velocity right now, he's just literally at 0 velocity, is he like stops, then turns around. And I don't know if that will be fixed if I do something else. Anyway, we'll get there. So cool. At least we got him animating the right way and exactly how we want it. And I bet if we get a little closer, yeah, he's glitching out just because. Like, you see he's walking too if I get it close enough, because the forward doesn't get a chance to go all the way to 1. But then he does get to 1, and it's kind of weird. But okay, we're getting there. We're getting there. So we have our animator with the right values. We know like, hey, we got the forward amount and the turn amount, so that's beautiful. Now we just kind of need to tell the rest of the world what to do based on the animator's movements. So this is kind of where things get interesting. Because how do you do this? Who do you affect? Do you just affect the position? Do you affect the rigid body? I'm going to go with rigid body because that is ultimately what we want to move around. So I'm going to pull up the script one more time, the what's it called? Third person character script. And I'm going to see if they have the on animator. Let me see what else they're doing on update animator. They're doing a whole bunch of stuff for checking for jumping and stuff, and we're not there yet. Oh, but there is a speed thing. We should do the speed thing too, because depending on how fast you want them to move on the nav mesh agent really affects the speed of the animation. So for now, I won't actually code it, but let's just put a to do here. Add animator speed based on nav mesh speed. Okay, excellent. Alright, so we got the moving, we got the updated the animator. I want the on animator move. Is that in here? Yes. So what are they doing? They are messing with the rigid body, but they're just straight out saying, hey, this is your velocity. So you're not really adding any forces or anything. You are just saying, hey, this is your velocity, go. No matter what's in front of you, just go. But it did make a liar out of me earlier, and it said like I was able to be stopped by something like that was 200 kilograms, but I didn't really need to be very heavy to push that 200 kilogram thing. Like I only had to be 20 kilograms before I can push that 200 kilogram block. So I feel like that's still very faulty. Like you still have like almost an infinite amount of force, even if you're a little tiny weak light person. So I really want to kind of like limit that. Like I just want to add the force that you should have as a light person, you know. So here we go. So basically this one's saying if it's grounded and the time delta is greater than 0. I do agree with that. I don't know about the whole grounded thing yet, but if delta time is greater than 0, let's just get a velocity. So how they got their velocity was animator delta position times the speed multiplier. We haven't done anything with speed yet, so what we're gonna do is we're just gonna get a vector 3 velocity. I like to spell things out. And we're just gonna get the animator delta position divided by time dot delta time. So that is velocity. A change in position over the change in time is velocity. Awesome. We are going to preserve, that's the way you say it, right? We are going to preserve the rigid body's velocity, whether he's falling to the ground, because earlier you saw if you have something battling the rigid body, the guy kind of floats as he falls, so especially with gravity and stuff. So preserve the rigid body's velocity by saying velocity equals rigid body dot velocity dot y. And finally, we're going to use the add force method, so it's going to be a little different than what we have on the right here, but not too different for now. No, it's going to be different because that just gives us velocity. We want the change in velocity. So here we go. This is all extra work. Don't worry, we're going to delete it. I just want to make it work for now. So the delta velocity is going to be, where do I want to be? That's always your first, like I want to be at velocity. So I want to be at velocity, but I'm going to subtract out the how I'm currently moving right now. Cool. And then you just rigid body add force that. Add force, rigid body add force. What am I adding force? I'm adding delta velocity, and the force mode is a velocity change. So this is really no better than this, really, but at least I'm using the add force as opposed to directly setting the velocity. Is that it? Let's see. I can keep going back and forth with the script, or I can just hit play and see what happens. Oh, he's glitchy. Name him Glitch. What's happening? Why is he going crazy? Oh, the turning works pretty good though, but he is glitchy. Something's I think messing up on the forward speed or something. And maybe a good way to debug that is we can make like all these variable serializable fields, and you can just see what's happening right in the in your Unity editor. So I might do that. Well, actually, turn amount should always be what it's actually already in there, so I should just be looking at that number up here, figuring out what's going on. Alright, so when nothing happens, 0, 0. Awesome. I click somewhere, he's going one speed, perfect, that's what I want. And then he's like 0.1, 0, then jumps to like a crazy number. Like, I can't see what that crazy number is, but man. It's pretty funny looking though. If you're trying to go for that effect, man, that's how you do it. Alright. So I really couldn't see anything. And why do I have so many Visual Studio open? You look like you're extra. Yeah, that's all I want. My 2. What am I doing? Figure out what in the world I gotta do. Alright. Time, 49 minutes. Crazy. Alright. Let's see. Where am I going wrong here? Hey, Mr. Cryptic YT. Sorry, I don't have timestamps or anything, so I don't know how long ago you said hi, but just throwing a shout out. Alright, so what I'm trying to do is figure out, so forward movement. Alright, so forward amount is always going to be Z. Alright, so let's just go through this by the loop. Alright, so we're going to detect, click, and set destination. Cool. That should not do very much except just get the input and set the destination. Cool. I don't even need these parentheses just to make it look even nicer. Alright. Animator, set float. Oh, ho, 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 ho. The bug exposes itself. There we go. That line of code, I'm already setting float forward to something totally different. So, need to get rid of that. Next, nav mesh agent's good there. Move update this desired velocity divided speed. Awesome, awesome. Alright. Glitch hopefully goes away. Oh, okay. Better, but not the best. Still something screwing up. Alright, let's keep going. Let's keep going through our thing. Alright, so move update is our next function. So if we go to move update, what it's doing is it's getting the magnitude of the desired velocity divided by the speed. So if this is close to 0, then this should be close to 0. That's good. If it's greater than 1, yeah, then it normalizes. Otherwise, it shouldn't normalize. Okay, cool. Maybe I should project this on the plane. Alright, anyway, we get the global to local, so that's great. We project it on the plane. What I'm going to do is just call this ground normal. And ground normal is just what's the normal from the ground, which is a vector that's pointing straight up by default on a flat surface. And so that's what we'll call it. Ground normal equals vector 3 dot up. And it's like, what are you talking about? There is no ground normal. Like, yeah, there is. There it is. So, okay, I did project it on the plane, so maybe that had something to do with it that I don't understand yet. A tan 2 xz, forward amount is the z. Apply extra rotation, yep, and that goes from the stationary to the with the forward amount, and then we apply that rotation. Okay, so we are hard rotating it, which is okay because we constrained the rotation. So this line is literally doing the rotation of the character. We are not using this anymore, so I'm going to delete it because we really aren't using this anymore. And with that being said, we're not even using our fixed update anymore. Shame. Okay, and the detect clicked. Cool. Later, I should probably put this all in the right order. Maybe I'll do that now. So I have my detect click first. My apply extra rotation is actually after this. Yeah, I think it was like that. Alright, cool. I don't know what's going on, so I'm going to have to look at it again. See if I can just kind of see the bug with my eyes. Alright, so forward. Forward's not even getting to 1 for some reason. It's like 0.999999. Then he goes crazy. I don't know. Bugs, right? That's going to be like the next 10-20 minutes of this stream. Yeah, C#. Well, I don't know. Like C# is like one of the easier languages to learn. You know, C#'s very Java-esque. So it's like very high level, no pointers, none of that crap, right? Like it's just here are your variables and here are your functions. And it's as long as you understand what's happening in your functions, which I mean that's complicated no matter what language you learn. Like if you're going to do game programming or something, it's like you got to understand every piece. Like you can't just and some I guess packages you can say add.character and then just say what sprite sheets you want to use and everything. But if you really want to get like a good I I don't know, very good custom feel to what you want to do. Like you got to know some of the C sharp and some of these like what Unity provides and what it does. So it's like reading a lot of Unity documentation more than like C sharp documentation, because the C sharp stuff's easy. Like it's here are your variables and here are your functions. But like the Unity stuff is where it gets complicated. But it's such a robust system that you can customize to do whatever you want. Anyway, yeah. But I started off just like that, like HTML, CSS, some JavaScript. And slowly but surely I started assimilating other languages. Like I did some Java, did some Lua. Lua was pretty good. But I picked up C Sharp when I started programming a little bit in XNA. But I didn't get very far. Cause man, I'm just not very good at like making a game. Like I just kind of stop somewhere in the middle where I should just be going. So that's what I'm making the stream. You know, I'm hoping I can kind of talk my way through a whole game if I can't just sit down and do it myself. You know. All right, back to this. So for some reason, when he's getting slow, he's really going fast. And that just might be something in my understanding. I'm going to cheat and look at my other code. Maybe I solved this already. I think it's here. Humanoid movement. Oh good, another Visual Studio window. Exactly what I wanted. It just knows. It knows that I love being annoyed by all these extra things. Okay, humanoid movement. And I'm doing jump and all that, so this is kind of crazy. So we're normalizing it, inversing, we're checking the ground status. Maybe it's something to do with checking the ground status that just isn't here. Alright, what happens when we check the ground status? Oh lord, there's like stuff that's happening. Oh cool, it draws a line. Alright, so when we're checking the ground status, we're just checking if there's a ray from the character a little bit up in the character shooting down. And to check ground distance is a variable, which is like how far away from the ground you need to be before you're considered on the ground. So the normal is basically the normal of what you hit is grounded, and apply root motion equals true. Apply root motion equals true. Sorry, just thinking. Don't know what's happening with my brain. Alright, update animator. Oh. It has some kind of dampening effect. I don't have any of that. I just have this first part. But if I look at the set float, oh, because this is off of it. But yeah, if I look at the set float, and I did exactly that, 0.1f time dot delta time. I wonder if that's the secret to all of this. So the float is that 0.1 is the dampening time, and then the delta time is the delta time. All right. So I wonder if that is the secret to all of this craziness. Tell you what, at least he's like on point. I know he's kind of going crazy on the turning thing, but I think that's only because I don't have a stopping distance, and like he's never truly on his spot if if the rigid body's always kind of moving around. So this might be right. So if he's running this way, yeah, that's the only thing I don't like is when he stops and turns around. Like, he can't just stop on a dime, right? Like, he has to slow down. But anywhere other angles like look great. Like even if he even if you're doing this, right? Like that all looks fine. I just want him to transition correctly, right? Alright, so I'm feeling okay about... I'm not even feeling okay about that. What am I thinking? Forward has to be somewhere between 0 and 1, right? And I'm not sure if I'm doing that, am I? Forward amount, yeah. Let's start getting our code back exposed. Alright, so desired velocity divided by speed. That should totally be something that's like 1 or... Alright, let's even just use velocity. Let's forget that I'm saying desired velocity. So his velocity will be how fast he accelerates. Yeah, I have to use velocity because what desired velocity is like full speed ahead, no matter what direction. So if I want to use the acceleration portion of the nav mesh agent, like I should really use the velocity. That way he goes like, I'm going a little faster. Now I'm at full speed. So yeah, I should have used that. And this is his full speed. So instead of always being 1, I guess now that should be a little more dampened. Yeah, that makes sense. Goodness, let's just try that. I mean, I know it's still not the fix, but it should be closer. Oh yeah, I like velocity because at least now he slows down. Like you can tell that in the animation. Alright, let's look at our nav mesh agent stuff. Auto braking, which is good, but he has no stopping distance, so he'll never stop. So if I hit 1, he'll, in a 1 radius, he'll stop. So yeah, that's good, right? He actually stops now. He doesn't freak out. I mean, he does a little like weird turn thing at the end, but I guess it's not the worst thing in the world. Not yet, but I do want this to work perfectly. I'm all about that. So you can run around this this sphere. Yeah, I don't get the whole like it twitching and while it tries to stop, but we can kind of get a better visual feel for it if I go here, do Shift F. I'll kind of rotate it, do the navigation. We'll get like a... Oops! I meant to hit play. So okay, as he's stopping, yeah, you can see like that, well, first of all, you see desired velocity goes crazy sometimes. And that's just because we use a rigid body and we're using the physics. So like when he's at his destination, we really should have like a 0 velocity. But you'll notice that the black arrow, which you can see the black arrow when I do a crazy spin like that, but the black arrow is very small when the blue arrow is wigging out, so that's why he kind of looks better. Not much better. And then if I go to the nav mesh agent itself and set the braking again, where is it? Here it is. Cool. And then go back to navigation, hit play. Like it snaps back. Like it's like, whoa, you passed your destination for a second. You better not do that. I feel like if you're within stopping distance, you shouldn't turn. Right? Like just stay your course. And this is a bug I still have even in my code, like the one I worked on previously. So that's how we're gonna fix it though. We're gonna stop it. Right? We're gonna stop turning it when you're within the stopping distance. No more turning until you are outside of your stopping distance. I think that's the best way to handle it. But yeah, I mean, besides that, this is awesome because look, his footsteps Awesome. They're working pretty well. But the part I'm going to complain about is the way we're handling the rigid body right now. We're handling it by just adding a force, and it doesn't. There's really no cap to that force. So we can push really heavy things. So if we look at our inspector, I am 1 mass, 1 kilogram. This block, which I'll move over here, make it kind of bigger. I'll make this 10 kilograms. Can I move this block? Yes, and too easily in my opinion. I shouldn't be able to, but I do. And that's because my animator script's saying, hey, your velocity, just make sure it's what the animator's saying. Don't worry about anything else. Just apply as much force as you need. So that's problem 1. But I know if I make it too extreme, it actually stops it. I'm still pushing it a bit, which is crazy. You can see that here. It's like it's moving, and it's literally 30 times heavier than I am. So you know that this is applying too much force. So how do we handle it? I handled it. I handled it in the other script. So we're gonna cheat and use my old script because there was math and physics involved, and I can't remember it on this fly. So we'll look at it here. It's not the third person character, so I'm going to close this out. It's the humanoid movement. Alright. And I might have put a hard-coded thing in here, which I'll probably have to take out eventually. Alright, here we go. I have animator velocity and change in velocity. So let's grab that stuff first. So on animator move, if the time is greater than 0, because we don't want anything divisible by 0. So for some reason it updates the frame twice and there's no delta time. We don't want to divide by 0. Which I don't think it ever should, but anyway. So we got our velocity, so maybe I'll just keep that. Animator velocity. That's what we called it. That's what I will name it here. Shoot. I can just control RR. Animator velocity. Cool. So that's our animator velocity. We also get another thing called, I call it change velocity, but we'll call it delta velocity here. Delta velocity. It's going to be our animator velocity without the underscore. Animator velocity. If I can spell. I really can't spell. Did I spell it right the first time? Animator velocity. Yep. Minus rigid body dot velocity. So that's the change in velocity. My animator is saying I should be doing this. My rigid body is saying I'm doing that. So if I subtract the rigid body's velocity from the animator velocity, we get where we should be going. I say the change in velocity, yes, instead of doing all of that, delta velocity dot y, it's going to be 0. There is no change in velocity, at least based on the animator. So the rigid body, we're only going to put the xy force on there, no y force. We'll let gravity and other things handle that. Delta velocity, wait, that's what I said. Where am I? Who am I? Okay, so I got the y. Okay, cool. Let's get other stuff. We're gonna get the mass, which is rigid body dot mass. I don't know if this is necessary to make it a local variable, but sometimes it's just nicer to see things. Force. What force? Oh, I think I'm using force as a. Why is force there? Did we not specify it earlier somehow? Let us get the definitions now that I know how to. Oh, it's humanoid movement though, so I can't. Darn you, force. well, since we're not using it anywhere else right now, I'm going to just call it a vector3 force. I probably made it a public variable so I can see what the force was when I was debugging it, but not doing that now. Mass times delta velocity divided by time. I gotta do dot delta time, not fixed delta time, because animator is moving on. Yeah, it could be moving on its own thing. Like, I wonder if there's like animator time. What kind of times we got? Time. We have fixed delta time, maximum delta time, smooth time scale, unscaled time. Yeah, let's just do delta time. Or does it run on fixed time? Fixed delta time. I am going to do delta time. Okay, and so now we're just going to do a check. If force dot magnitude is greater than, and this is where I have a hard coded something that I need to understand better. But basically I'm saying if the force is way too strong, like if it's faster than your speed times 5, I really feel like mass should be involved in this calculation somewhere. But anyway, for now it's just times 5 for no good reason. Go ahead and basically cap it out at that point. So you're clamping it. You're like, yeah, you can't go faster. You can't push more than nav mesh speed times 5. I don't know why I chose that, but I'm gonna name this something so I can easily change this later. Force, max force, right? That's the name of this. I'm gonna say all of that is actually that. So if your force is greater than max force, please cap it and make it max force. Oh, sorry, I'm standing on the ground, so my head's really low on my webcam. So I think that's it. Did I do it wrong? Normalized. Cool. So is that what I want to do? Awesome. We have an actual force. Nothing crazy, no weird force modes. We're just adding this force. And that, I think, my friends, is how you limit crazy forces with your animator moving mesh guy. Oh gosh, he can't even move that 1K block. He has to run over it. So he can push it, but it's hard for him to push something his own weight, which it should be. He shouldn't have an easy time doing this. But if nothing else is around, he runs just fine. It looks like nothing else is capping him from running at his speed. So like I said, what we've done so far is we're using 3 different movement engines. The nav mesh agents actually can control our speed and our acceleration. Angular speed is nothing, so I can make that 0 just for visual purposes. Like, angular speed doesn't affect it at all. These 2 will, and I still have to write code for the animator to be affected by this speed. Rigid body is doing its thing. All we're doing is adding forces to it based on nav mesh agent, and really based off the animator. So, how fast does the animation need to be to move at nav mesh agent speed? That is a good question. And this is how I tackled it. There might be a different way, a better way, but I'm going to tell you how I tackled it. Thank you, ZXFlame15. Sorry, I'm reading some of the chat right now. Hey, man. All right. The chat says that I'm looking at Shocking Truth. Yeah, man. I I have confidence that you can do it, man. If I can do it, you got it, dude. You can do it. All right. So right now we got the nav mesh agent, rigid body, and the animator. Is Twitch lagging? Yeah, maybe because I don't have very many dropped frames. I only have like zero point 0.7 drop frames in the last hour. 0.7%. So that's not too much. Yeah, I think so. I think it's E-Man. Uh, oh yeah, so I'm asking the question. Speed. How does the nav mesh agent speed affect the animator speed? Well, this is what I did. I went to the third person character's animation that we stole from Unity. Went to humanoid run, right? And if we look at the humanoid run, you get the average velocity right there. He's running at, when the animation's running at a speed of 1, his movement is 5.661. And then if you look at humanoid walk, his animation's at 1.559. So I think I just used the run because that will give us kind of our cap. Like, hey, when I'm running at my fastest, I want to be running at this speed. So just remember this number, and I'm going to put it in the Visual Studio, 5.661. Where am I going to put it? Where am I going to put it? Before I forget it. Oh my gosh. Better just put it somewhere. 5.661. Alright. So what are we doing? We gotta make sure the nav mesh, no, that the animator speed has something to do with this. Oh, we're in the right function. Oh, and we're on the 2D thing. Okay. So this is what we got to do. The animator speed has to be set to something based on the speed of the nav mesh agent. So the nav mesh agent speed. So if the nav mesh agent speed is 5.661, we want this to be 1. But if the nav mesh speed is greater than that, yes, I think I'm doing this right. I think it's just nav mesh agent speed divided by 5, this thing. I'm hoping that's right. Oh, I could look here in my cheat area. Update animation. That's one of the functions. Is it just here? Come on, where is dot speed in this thing? Yeah. There you go. Yeah, oh, and it was the same thing. Animator speed equals nav mesh speed divided by 5.661. Okay, so why did I do that? I am doing that because now we can have a modifiable speed for our character. So where is everybody? Alright, so right now if I look at player, he's running at 3.5. So if I play that, that's the speed in which he runs. Oh my gosh, it's so slow. But I think that's what we wanted, because now I think it's all based on this guy. So if we made this 5.661, he'll be moving at the speed he is intended to move. Like, that's what the animator told us to do. But if we wanted him to run a little faster, we can make this like 20, right? And I know I gotta fix a lot of junk. Oh gosh, I don't think that's right either. What's he doing? He's walking. I don't know what he's doing. Is that something to do with this thing too? Should I make this like 100? Oh, I'm gonna walk over there. Oh. Alright, sorry. So I did something wrong. I don't know what it is. Animator.speed is navmeshagent.speed. That makes sense. But what is wrong? Something is wrong. It's obviously something wrong. Because he is just walking instead of running. Oh. Oh, I know. It's this thing. What did I actually use when I'm updating the move? So on the update function, when I'm calling move update, move is just, alright, nav mesh agent speed, oh yeah, some crazy thing. True desired velocity. Okay. I think I understand. I think I understand. I think I understand. Alright, so this whole thing, I was talking about this, I think it's kind of BS. I think this is going to be the velocity you want, but I also made it that you want to move at a velocity towards, instead of me just saying all this, like, I think it's just navmeshagent.velocity. And if I really want it to be, like, if I really wanted him to move towards a direction, like, he really wants to move towards the desired velocity, right? But we also want to take into account the acceleration. So, what am I trying to say here? It's like his true desired velocity, or actually just true velocity, right? It's not true either. Let me just come up with a good name, that way this makes sense later. Let's just call this the animator desired velocity. It's how fast do we want the animator to actually go in what direction. And that would be the nav mesh agent desired velocity normalized times, so we're getting the actual direction we want to go, but we're getting the speed that nav mesh agent's telling us to go, so times the magnitude. So we're kind of using the acceleration portion of the velocity, but we're aiming it at the desired velocity. I hope that makes sense. If it doesn't, I know it's complicated. You'll have to like think about it really hard. But I think that will do it. I almost forgot what we're doing, but I think. So okay, he's running at full speed. I really got to do that. And that's why I have the whole slow radius thing. Did I still have, man, I still have stopping distance at 0. Let's make it 1. So yeah, he's super slow. But yeah, now he stops at least with the stopping distance of 1. Alright, so the true intentional velocity is 5.661, so if he's running at that, that's what the animation was supposed to be running at. Oh my gosh, almost an hour, 30 minutes already. Okay, and but then if we made it really fast, he should still look kind of natural. Okay, maybe that's too fast. But if I did it like double his speed. Like, and the reason I want this is I want his feet to like land. I don't want it to slide, and so that's why we did all this crazy stuff. Just because I want all my animations and everything to look great after this. I don't want it to. I don't want to do tweaking for every model. I want basically one code to fit all models and animations. So that looks pretty good, I think. No feet sliding, no weird looking. He just does his thing. Alright, man. Take it easy. Shocking truth. Yeah, alright, dude. Good luck with that. I hope you fix it. Become a good programmer. Teach me, hire me when you get a big successful game company. Later, dude. Alright, so what are we doing? We got this. He's running around. I mean, I think that's all I really wanted to take this whole movement thing. I can add the different things, the different variables for him to jump and crouch, but that's just kind of extra work, like stuff that doesn't really, that won't matter right now for the gameplay. Because really, my gameplay is I'm gonna have a guy running around, and then I just want him to like sit down and then look at something on the ground, and eventually that something will be a place where he can build a sandcastle. But until then, that is all I need. I just need him to run around, and he's doing just that. And I want him to have like a realistic force. So like if this box is, where's that box? If this box is like 10 times heavier than him, he should not be able to move it. And he doesn't. But if the box is a little less, nope. Even like 4 times, he has a very hard time moving it. So that's perfect. That's exactly what I want. Yeah, I mean, that's great. I think that looks good. Other things I can do, or the other things I was telling you about crouching and stuff, is when you want to check for crouching, you're just going to draw a ray cast. Like, just like we did for the mouse, where our mouse pointer is, we can like actually press the button and it'll cast a ray from the camera down to the ground, and it'll find out what that hit point was. We're going to do another kind of ray from his feet down to the ground, and then usually you make it like 0.1, 0.2 to figure out how if that little ray intersects the ground, and if it does, that means he's able to jump. And another thing I was thinking of doing, which I haven't implemented yet, is cast a ray in front of him. So if he has like a box in front of him, go to like a push motion instead of just running at the box. So right now he just runs into the box and he just does nothing. So a push animation, like think like Sonic the Hedgehog. Like if you push against a wall, he goes like that. So yeah, that's all I really had for today. I'm gonna make this kind of a. I want them to be fast, but I don't want them to look silly. So I'm just trying to find a fast speed that doesn't look silly. I think that looks good. He just looks kind of silly pushing against the box, but if I get a pushing animation, it'll look better. Maybe I can get like a pushing velocity, like how fast is he actually moving, and then kind of put that into the animator. But anyway, man, it just looks good. I just love the Unity animator thing. It looks great. Like even when he's doing turns and stuff, like it just, you can tell like he's actually moving his legs. It's not just like an immediate turn. All right. Anyway, I'll stop admiring it. All right, let's look at our topics, see what we discussed, see what we need, what's left. Here we go. Read me. So, putting it all together, we did that this episode. We basically got a rigid body, nav mesh agent, and animator to talk together to make the guy move around the plane, but make it like a good rigid body movement, and at the same time using the animator to control the speed of the movement so that the animation looks fluid. So that is what we did. These last like 3 episodes is actually what we did. And so we got a movement engine down. We can do bonus, which is not going to be here, so I guess I shouldn't put in episode 3. We'll just call this like episode 3 bonus. I don't know. More. We'll just call this part bonus. Bonus. Add jump and crouch, which I might do. This won't be like a full featured episode. This will just be like, hey, I'm here for like 15 minutes. Let's go ahead and get that done. And then episode 4 is when we'll get camera movement and stuff. hopefully I can get both of these done within the hour. If I can do that, be great. And another bonus thing, big picture planning. Let's kind of figure out what do we need to do next. What are the next steps we need to do to make this game work? Like I said, the game is going to be called Sand City so far. You're a guy, boy or girl, running around the beach. You can build sand castles. If you build too far away from the sand, all you can do is build like mounds. If you're at the right spot on the beach, you can build sand castles and like mold things and stuff like that. And then the water is going to wash it away eventually. But I might add some cool like sea life or something to make it a little more dynamic. Maybe make like a tower defense mini game in there, where your castle has to defend against sea life or something crazy. But I really want the sand castle building mechanic next. So we're gonna, but I want you to kind of walk around the beach and get that feel too. So that's why we're this top-down starting point. But then you're gonna zoom in to like a first-person look at the sand when you're sitting down on the ground, and you can kind of like dig. Yeah, so the mechanics are you can dig. And so like when you dig, you make a little mound on the side, but you make a little indentation in the world. And you just keep digging, digging. And you can either keep building that mound, or you can like dig and then like tap your bucket and you'll put that sand in a bucket. And so you keep digging, putting sand in the bucket, digging, putting sand in the bucket. And then you'll have your bucket full of sand, and you can like put that down somewhere. And if you put it down, if you got dry sand will just collapse into a mound. If you got wet sand, it'll stick. And so then you have your like first structure. And my plan is you just kind of build structures, either like circular bucket looking things, little walls. And so you can build your structures, and then if water hits it, it'll slowly eat away its life, but if a big old wave comes, it'll be like a big hit. So these are the plans I have for this game. And if you build it on dry sand, you're not really building a sandcastle. That's why you just keep getting mounds and mounds. But you can build a hole in the dry sand, and it's not really going to do anything. Maybe you can trap players in there. I don't know, like a Load Runner or Dig Dug or something. But alright, I'm going to close out this feed. Hope it's been good. Sorry for the extended one. It's just I really wanted to get past this movement stuff before the next episode, because I'm really ready to move on to the next part. But I hope it makes sense, at least halfway. Hope I didn't make any mistakes. If you see something that I did along the way, let me know. Shoot a comment on my YouTube, because I'm posting these on YouTube, or send me a chat on my next stream. I will try to update my profile so it'll show what days I'm streaming and about what times I'll be streaming. And yeah, that's all I can think of. No questions in chat? Nope. Just that guy that got hacked and the other viewer that wants to learn C#, which is good. Good for him, man. He'll hope he does good. Alright. Alright, I'm alone in chat, so I am going to close out. Goodbye, Twitch. See you next time.